Okay, let's review very quickly what we have here so far. We started off by loading in a 3mm ball by 50mm long probe tip. We calibrated it. We loaded in our CAD model, and over here in the program window we started off by doing a plane manual alignment, which shows up here, and then we switched to DCC mode and created another plane alignment, which we call our DCC alignment. And we see over in this corner that we have our trihedron in perfect position on our part. Our origin is in this corner. Since then, we have taken measurement of this plane and of this plane and constructed a line down the center of this notch. And we did an auto cylinder measurement of this top cylinder here. So we have some really basic measurements in place. We really want to get some more measurements on this part in order to ensure that we have something real to report out. So on this part, I'm going to additionally measure the internal cylinder to this. There's another one deeper down in. We're also going to change the wrist angle in the program and measure this front cylinder here. And then we're going to change the wrist angle and make some measurements over on this side here. Additionally, I may take a stab at measuring this cone and this inverted sphere here, so that you can see some other measurements being done. Now, most of this I'm going to do on the CAD model because it's very simple, but we're going to test these features out each time before we move on. So I'm going to start by doing an auto cylinder, and we're going to select this inner cylinder. So I'm going to click down inside of there. You can see now that the lines all move down inside. It is a 20 diameter by 10 length cylinder. I'm going to move this up because I think in the last video we got a little obstructed by our picture-in-picture. So we have our location, we have our angles, diameter, start and finish angle. We just want to take a look at what we're doing here. So 3 hits per level, 1 depth, 3 ending offset, 3 level. Let's give it a test. So it didn't crash at the bottom of the cylinder. That's always a good sign. That's usually where we run into the most trouble. If you didn't set that ending offset correctly, it can be problematic. So it looks like it did that just fine. I'm going to create that and close that. Additionally, I think I might want to take some of these spheres up here, cylinders up here, so let's give one of these a try. Okay, that's an 8.2 diameter. Again, let's take a look at this. It's 10 length, so these features should all apply. I think I'm just going to go down to 2 levels for sake of speed, and let's test that out. That seemed to work quite nicely. So I'm going to create that. Now, one of the neat features about this auto cylinder is that I can just come over here to this next one. Since that one worked, I can just click on it and say create. Click on the next one, say create. Click on the next one, say create. And right on around, and this should work just perfectly because we tested the first one out. So this is a neat way of getting quick programming without spending a lot of time. So there we have all those cylinders done, quick and easy. I don't need to test them, I know that they will work. Now I told you before in the last video that we could construct a circle using all of those. So look at this, I've got all these cylinders lined up. Cylinder 1 and cylinder 2 were these two center cylinders here. So we start with 3 through 10. So really all I need to do is just select 3 through 10 in order and create it, and it's a done deal. Simple as that. So that's listed off as circle 1. Alright, we're going to take a look at this auto cone right here because I know you're interested in it. Let's give it a try. We're going to click over on it. So there it shows it. It is a length of -7. Let's take a look at our levels here. Our ending offset is going to have to be greater than 1. I can tell you that for a fact. Hits per level, we'll go down to 3. Do 2 levels. Let's bring our ending offset up to 3. Our depth down to 1. Now let's test it. Seemed to me like it missed it a little bit on its locating it, but there it is, testing it out. Seems to have worked, so we're going to create it. And let's try our sphere, because why not? So there it is. You might notice that some of these properties changed a little. This surface should say 0, 0, 1, and you should correct these when the time is right. The angle looks weird. Notice how all the lines here are pushed into one side of the sphere. I think we really want to change this angle to 1, 0, 0. Let's see how that looks. And it has weird start angle info here. We want to go 0 to 360. And start angle, end angle. Same thing here. 0 to 360. But that shows a complete circle, so let's try 180 here. And levels, notice this dialog looks a lot different. 3 rows, 9 hits. Let's test it out. Well, it really missed. So you can see this doesn't always work perfectly. For some reason it did not like the location of that. So we're going to try this again. It is an error. Should have worked on the CAD drawing, but it really didn't. Alright, I'm going to abandon this because it's going to take too long to figure out. We're not going to create that. Alright, I want to show you now how we would change a wrist angle. If this were an automated wrist, you would simply create the command in here from one of the angles that we already calibrated, and the wrist would move automatically. Something to keep in mind, you should always retract your arm and keep it fairly well centered when your wrist moves. There is a way to do this. I was going to wait for a later lesson, but I'll give you a taste of it. If you go ahead and move the probe up like this, you can create a move command by pressing this arrow or by selecting from the main menu a move command. And what that will do is move your arm to that position each time before you execute your wrist movement. It's a real good idea to bring it to center if you're ever going to do something like that. In our case, we're going to change the angle in the software here up at this tag right here. So the drop down for the face of this would be 90-degree angle at 180. So what we're saying is if I selected this, it's going to put it in the software now, and it's going to come with this little pop-up that says okay to rotate the wrist to T1, A90, B180, and we'll say yes. So what that means is we're taking A angle to 90 and we're rotating the wrist to 180 degrees. If this was automated, that command would automatically create that condition. In our case it's manual, but there will be a pop-up that will come up to alert the operator to make that change. So now you can see that we can come up here and make measurements on this face a little bit more accurately, especially for this inset stuff that we have here. So let's talk about this measurement. Same sort of thing. We want to measure this part of the cylinder right here. Move that out of the way so you can see a little better. So this is the cylinder we want to measure. We can use an automated measurement there, or we could do it manually. Let's do a manual measured cylinder here so you can see that being performed. So same sort of thing, we can work with it right here on the CAD model by selecting program mode, and I can pick measurements right on the face here that I feel are going to be beneficial to us. So remember, with a cylinder you want to try to get 3 hits on a plane, and then you want to get some hits inside of there. A little tricky, you don't want to go too deep or the ball might contact the back of the cylinder. So you want to make sure you at least leave a little bit of room from the back so the probe doesn't hopefully crash when you go to make this measurement. Now, we just did this one thing, and we kind of like to test it out, make sure that it works properly. So let me do something here first. Since we made that change, we want to make sure that we have the probe in a position where it's safe. So I'm going to put a move command in. And I'm going to bring the probe down in front and make another move command. And now let me accept the shape that I plan to measure, like that. So now you see we have cylinder 11 listed there. Now a neat way to test this out is to put the cursor just in front of this last command and say Control U. It's a shortcut. It allows us to run just that one line item. So here it goes. It's going to try it out. Problem, right? Why did that happen? Well, the probe always wants to move in a direct line with the next measurement. So that's problematic for this measurement that we're trying to make. It's going to crash every single time unless we do something to prevent that. So There is a nifty little command that we can use in here called a clearance cube, which will make it so that the probe will always move outside of a certain distance each time between measurements. I'm not going to go into that here because that's really something I want to do at a later lesson, but I wanted to show you sort of the pitfalls associated with making a measurement like this. If there was nothing in the center of this cylinder, it would be easy, no problem at all. We'd do this measurement in our sleep, but because there's that center piece there, it makes it a little trickier. I could put a move command each time between each measurement. It's kind of tedious, but you can do that. Just wanted to sort of demonstrate how this works, but it is a little bit trickier than most. I'm going to just get rid of this last bunch of stuff here, including our tip angle change. So I just took that out of there. If the probe crashed really, really hard, you might find that this power button has turned off. To repower the instrument, you have to hold this down for a few seconds. In this case, the crash was so light I should be able to just back it out. But that's not always the case. I wanted you to be aware that these kinds of things happen. The left face should be a little bit easier to do work with. I will again change our tip angle. This time I'm going to go to T1, A90, B90. It's going to prompt me to move the wrist. All we're doing here with this particular one is changing to this orientation. So we are now at, so you probably can't even see this. We are now at 90 degrees and 90-degree angle. So we should be able to make measurements on this side, especially in here. This is where I would be most concerned with it. So if we wanted to actually make measurements of this slot here, we can do that. We could put our guess on, and we can make some measurements inside of here, say right here. It's not in program mode. Right here and right there, and we'll call that a line. And we can also tip this model up a little bit easier and get up under here and make another line right there. Except that we have another line. We could test those features out again using the Control U. And it doesn't like it. Interesting. Probe hit didn't occur. That really wasn't what I was expecting there. I expected that to run. So I don't know why that didn't work. That's why we test these things. Because you never know if they're going to work or not. Let's try line 3. Maybe that one will work. That one worked. I don't know. Interesting. But that's why we do this. Maybe if I did this line 2 a little differently. Let's get rid of it. Let's try programming it directly. We'll bring this over and down. Move it in a hair. Slow it down to turtle speed here and drop a point. And we'll bring it over and drop another point. We'll accept that. And that came up as line 2. So now let's try it out. Okay, we're going to try out that last feature here. It's our line 2 feature. Control U. Say OK. and that worked. So the important thing is to always test these features. The Control U feature is a really great way of just testing a particular line that you programmed. There are other Control Plus letters that do things for you. There's a whole slew of them. Anyway, you can find all that stuff in the help file if you're so interested. So we have some features here. I wanted to just measure a few other things for you so you got a sense of what we were doing. Now let's talk a little bit about these location dimensions. So these are your GD&T symbols right out of a print. You can see here we have location dimension, position dimension, distance, angle, concentricity, coaxiality, circularity, cylindricity, straightness, flatness, perpendicularity, parallelism, total runout, circular runout, profile surface dimension, profile line dimension, angularity dimension, and symmetry dimension. So these all work just a little bit differently than each other. It depends on which one you select. You're going to get a different dialog box associated with it. But each one of these is going to ask you to specify information about the measurement you're trying to make. So let's start with a location dimension. We want to locate a particular feature, let's say the first cylinder that we measured. That's this particular one here. All we really need to do is click on that particular feature, and up here we have the axes that we want to measure. In the auto setting, it's going to give you the X and Y distance from this origin, and it's going to give you the diameter of this particular feature. And we have a nominal size here already down as 30, and let's see, it's in millimeters. You know, there are some features in here that you can play around with if you like. It's really up to you. Currently the ID is called location 1. We could change it if we want. We could say top circle location. And that way when you get your report out, it knows where it is. Yeah, I wanted to end this, put this at the end of the measurement routine. So there it is. You'll see down here in the bottom in the status window, it shows you all the information that we just put out. This shows you that, you know, the thing is dead nuts. It's exactly where it should be. Everything is perfect about this. If this were off, it'd tell you how much that it deviated, how much the out tolerance was, and this bar would show you a little bit of information about it. Let's move on to the next one here. Let's go to position dimension. So this one requires that you create datum references for it. So you'll notice down in this box there are no datums listed right now. We need to define those. So if we come up here to datum definitions, it's going to give us this listing over here. So our datums in this case are these planes. Planes A1, B1, C1. Those were our DCC measured planes. So datum A is our plane A1. We're going to create that. It associates it. Plane B1 is B. Plane C1 is C. And now I can close that. And now we show our datums over here. So if we want to take a look at a particular location, let's say we want to look at cylinder 3. So it says datums are required for this. We're talking about this cylinder right here. It needs to be located with some frame of reference, so we need to select references for it. So datum A is probably not going to give us a lot since datum A is this plane. Let's say we want our primary datums to be B and C. Now this is really going to be called out by your print. The things that you need to measure should be specified up front with your drawing, so it's incumbent on you to understand the best way to measure this. If we're all set, we create this, and now you see we've created this whole feature control frame here to go with this. Simple as that. Here is our status window, and you can see what it's telling us about this particular feature is that cylinder 3 is not located exactly where it should be, or it would be in the dead center of this circle. And so there's additional information about how much it is deviated here. All this will show up in a report at the end, so when you run your final version of this, you will get a report at the very end, which you can view here by going to View, Report window, and this will bring up your entire report. This report can be printed out, which is ideally what you would do. Additionally, if you make changes to this program and want to see the same report done again, you can click this redraw the report thing here, and it will restatus the report based on changes you've made. So there's that. So here's where you find it in View, Report window, Edit window, Graphic display window. You can turn on and off these things if you don't really want to see them, but it's recommended that you always keep the Graphic display window and the Edit window open when you're working in this software. Alright, let's check a distance. Okay, how about we pick these two lines here. We want to know the distance between those two lines. We know they are line 3 and line 2. We want to know the distance between. Our nominal is probably, I don't know if that's correct or not, so I'm not going to play with it. It says the nominal is 1.028. I'm not going to fight them on that too much. Something to consider though when you're making measurements like this, you want to make sure that you're working, when you're building lines, you want to make sure that you're going from y minus to y plus with both of these. If you're working along this side, you want to make sure you're always making your lines in the x plus direction. Always want to go from lowest to highest and keep that the same each time. Otherwise your measurements might turn out to be a little screwy in the end. So we're going to go ahead and create this. We'll close it. You could see here, this is all in red because it failed its tolerance, and you can see here by this bar that it is a bit out from where it's considered to be. So if that seemed really far out, you might want to look at your programming a little bit. You might even want to take a manual measurement and confirm that that's correct. So these are just some of our measurement features. You really need to play with all of these individually and understand how they work and see what the dialog boxes look like in them before you move on. That's just a little taste of this. Obviously it takes some practice to really be good at this.